Hello, my friends. Here's a brief tour of my VFD conversion for my Super 11. Let's start with the drive. This is an Invertek Opti drive. I liked it because it's purple. But seriously, I chose this because I liked the customer support from Invertek, and I wanted to use a commercial drive, figuring that might serve me better, and I did like the ergonomics of this particular drive. It's a 3 horsepower drive, which is more than double what's required, except for the fact that when you're going from 1-phase to 3-phase, you need to double the horsepower rating of the drive. Now let's go down to the control panel. Power to the system is applied via an NVR relay. So when I pop this button out, this latching button, it enables the power button, and this is a momentary button that will apply power to the NVR relay. So listen, and you can hear the relay click. The beauty of this is that any power interruption removes power to the whole system, including the VFD, and it's quite easy if you wanted to hook up additional interlocks, like for a cabinet or whatnot. Select a direction, reverse or forward, and green button for go. Okay, or red to stop, including electric braking. Okay, now if I want to change speed, just change the potentiometer. That's about 120 hertz frequency off the VFD, or I can run it down to 30 hertz or thereabouts. So let's take a look here. So we're at 30 hertz, 33 up to 120. This is using a 110 volt Emco motor, and with a little bit of experimenting I found that this works pretty nicely. I just got these button assemblies off of Amazon, and then I 3D printed some labels for them, so I put them in an arrangement that would be intuitive for me when I was threading, and I could operate the whole thing, including the panic stop, without looking at the panel at all, with the stop, electrically assisted brake stop on the top. I thought that was important. And then we just change direction, and this is very handy if I'm doing threading. The front panel is connected up to the junction box in the back of the Super 11 by this hose that's connected through this gland connection, so all the connections are watertight. I chose not to go through the face as others have done through the original switch hole, because I found it a little bit cramped for the number of control wires that I was using. Here's the junction box for the Super 11. My Super 11 has a mill head on it, so I'm capitalizing on the 110 volt input to feed that 24 volt DIN power supply via that single pole breaker on the left there. Otherwise, it's mostly unrelated to the VFD system. 240 volt mains comes in via that double pole breaker, and that double pole breaker feeds a 220 volt relay that you see in the back there. Let me see if I can focus a little bit better on that. So that is what's actually feeding the VFD. It goes up through the column on top of the cabinet there and up to the VFD, and then 3-phase coming out comes down the same way and into that blue reactor in the back. So that's an inductive reactor. Basically, it's three inductors, so ferrous core inductors all linked together on the same core, and those are used with induction motors as a filter to limit inrush current to the field windings. I felt that was important since I'm retrofitting this old motor and asking it to do something it was never meant to do originally. So yes, there is a protection cover missing under that breaker. I'll add the cover, and I may actually pull a whole DIN rail out and put it externally so I can locate the cabinet against a wall and still have ready access to it. Emco. 124 volts AC is fed through the small breaker, or the breaker on the left, and that feeds a 24 volt DC power supply. The power supply in turn feeds this NVR configured double pull, double throw relay. When I push the enable switch, watch what happens. You can see a circuit is made through the relay momentarily. So this energizes the relay.
Okay, and then as soon as that happens, one of the poles of the relay closes, and that causes the 24-volt relay power to go through itself, so it kind of winds back on itself and comes back around through the coil, and again finds a path to neutral. That e-stop button is, when it's popped out, it's normally closed. So if I hit that e-stop button, it's going to drop the latch on the relay and everything shuts off. Likewise, if the power just shuts off, the whole system is de-energized, it cannot come back on. Okay. All right, so the second pole of that 24-volt DC relay, that's the small one that's on the right side of the DIN rail there, to the right side of that double pole breaker. That's feeding 120 volts into the contactor, which is just a relay, a double pole single throw relay, right? And so in doing so, it energizes the contactor, and that's how we switch the 240 volt mains supply to the variable frequency drive. I hope that makes sense.
About the motor windings. So you can see this junction strip that I've put in here, or terminal strip, and I have access to all the field windings. So this is kind of nice, so if I ever wanted to change it, I could. Like I said, I have tried the Y configuration. It worked fine, the high-speed configuration on this Dollander motor, but I found that the delta actually was quieter, and then that also leaves me with the high torque capability of the motor as well. So that's what I've settled on. By the way, that capacitor there is only used for the mill head, not for the Super 11. The original Super 11 had a pair of capacitors additionally, for at least for the single phase units. Mine was a 110 volt unit. So there you have it. The Invertek VFD retrofitted onto an old Maximat Super 11. Thanks for watching. Bye.